Good morning. Myself Soni Simon from the Department of Zoology and Genetics. So today, in my previous class, I had basically told about what is an ecosystem, the structure and function of an ecosystem, and under this function of an ecosystem, I basically described two main roles that happens in an ecosystem. That is the nutrient cycle and the energy flow in an ecosystem. So I had just given you a brief idea about what is a nutrient cycle that occurs or that happens in an ecosystem. Now we'll be studying energy flow in an ecosystem in detail. Okay. So before we study energy flow in an ecosystem, we should basically understand what is an energy and how this energy flow is taking place. Now energy, as we all know, it is the ability to do work. The ability to do work is said to be the energy. Now, if we have to explain energy flow in an ecosystem, this energy flow in an ecosystem occurs or takes place under two laws of thermodynamics. We all know what are the two laws of thermodynamics. So, the first law of thermodynamics states that energy can neither be created nor be destroyed, but can be transformed from one form to the other. Now, what does this first law of thermodynamics states? Okay. Now, whenever any organisms in any trophic level gets their energy, okay, it is being transformed to the next trophic level. That means it is not being created as such, okay, or destroyed after that particular trophic level organisms is used, but in each trophic level there is an energy transfer that takes place. Now, for example, if you take plants which gets their radiant energy from the solar radiation, okay, they get basically the radiant energy or the light energy from the sun, and they absorb that particular energy, okay, for its process, it can be for respiration, photosynthesis, or metabolic processes. They use that particular energy. When the consumers feed these autotrophs, this basically what happens is the energy that is being transferred from the light, okay, that is now from the sun it is the light energy. The plants will get or will convert that light energy into the potential energy. When the consumers feeds on these plants or autotrophs, basically they will convert this potential energy into chemical energy. For this conversion of this chemical energy, it is basically happening from one trophic level to the other trophic level, as we all know. Okay. Now this chemical energy is being used for all other processes in that entire organism. Now, the second law of thermodynamics states that no energy transfer is 100% efficient. If there is an energy transfer, it should always be from a concentrated form to a dispersed form. Now, as I said, if it should be from a concentrated form or a dispersed form, and if it shouldn't be 100% efficient, that means some energy is lost in the form of heat. Okay. So basically, to describe how an energy flow takes place in an ecosystem, it is basically given by a pyramid-like structure where it basically describes the different levels in an ecosystem based on the trophic level. So the base of a pyramid will consist of a producer. Further, it will have a primary consumer, secondary consumer, and the tertiary consumer. From all these, the energy is again transferred into the decomposers. Now, whenever I say decomposers, it can be a two-way cycle. The decomposers basically can transfer their energy or get their energy from the producers as well. So the consumers also get their energy from a part of their energy from the producers. So the decomposers and the consumers are directly or indirectly dependent on the producers. Now, whenever I say there is an ecosystem or there is an energy flow, okay, as I told you, it is not 100% efficient. Okay, so whenever we get the solar energy, we all know that these solar radiations falling on the surface of the earth, okay, not 100% of the energy is absorbed by the earth. Okay, there is only 56% of that total energy that is being absorbed by the earth, whereas 44% is almost reflected back. Out of this 56% of energy, okay, some amount of energy is received by the plants, okay, some by the animals, and some by the microorganisms, depending on the habitat, depending on how much of solar radiations falls on the surface of the earth. Okay, now if we should actually understand how our energy flow in an ecosystem takes place, okay, I have basically described, or I have basically drawn a small flow chart that explains how energy flow is taken place in an ecosystem with the energy that they get and how much of energy is being lost. That means both the laws of thermodynamics is actually being played here. Now, whenever we say energy flow in an ecosystem, it should always be in the form of grams calorie per year, okay, per square centimeter, okay, per square centimeter. Whenever we say energy flow in an ecosystem, it should always be with respect to time and the area that the energy transfer is taking place. So each and every time when there is an energy flow, it is always in the form of grams calorie per year per centimeter square. Okay, so here time is very, very important. It can be 1 year, it can be 10 years, okay, it can be just a season, okay, anything. So time plays a very, very important role. Here in this particular system, we basically explain with respect to per year or 1 year. Okay, now this flow chart basically will explain how much of solar radiations that the autotrophs receives and how much of this energy is being transferred to the herbivore and the carnivore, and in each stage how much of energy is lost in the form of decomposition, in the form of respiration, and in the form of not utilized energy. That means how much of energy is going in the form of heat. I told you some energy is going in the form of heat according to the second law of thermodynamics. So there is somewhere around 1,18,872 grams per calorie per year per centimeter square of energy that is received from the sun to the plants. Out of that, only somewhere around 80% is being transferred in some other form, whereas only 20% is being received by the autotrophs. Okay, when somewhere around 20%. So out of this, the 20% of this energy forms the 111.0 grams per calorie per centimeter square per year. Okay. Now, as I told you, when in each energy flow in an ecosystem, only 20% is getting transferred. Okay, whereas 80% of that received energy is being used by that particular organism. Okay, or that particular individuals in that particular trophic level. Now, somewhere around 111.0 grams per calorie per year per centimeter square is received by the autotrophs. Out of that, 3.0 is gone in the form of decomposition. That means here the microorganisms comes into action. Okay, the autotrophs, when it decomposes, the energy that it requires is somewhere around 3.0. Okay, some energy is lost in the form of not utilized energy, that is somewhere around 70.0. Okay, now some energy is metabolic or is used for respiration, that is somewhere around 23.0 is used for respiration. Now, as we all know, energy is required for all metabolic processes. It can be respiration, it can be excretion, it can be for digestion, circulation. For each and every process, the energy is required. So, whenever we are studying energy flow, we will just describe how much of energy is gone in the form of respiration. So, somewhere around 23.0 grams per calorie per year per centimeter square is gone in the form of respiration. Now, out of this, the only 20% of energy is gone to the next trophic level, that is called as the herbivore. Now, the herbivore, even when this herbivore has or this particular energy the herbivore gets from the autotrophs, From the herbivore also some amount of energy is lost in the form of decomposition. That is somewhere around 0.5 grams per calorie per year per centimeter square energy is lost in the form of decomposition. Whereas 7.0 in the form of not utilized energy and respiration 4.5. Okay. Out of this, okay, again only 20% gets transferred. Now the 20% is somewhere around 3.0. It is getting transferred to which trophic level? It is getting transferred to carnivore. Okay, which basically feed on the herbivores. Okay. Now for the process of carnivore, for the energy transfer in the form of carnivore, in carnivores, it basically takes a very trace amount of energy is lost for decomposition. Very less amount of energy is lost in the form of decomposition, and the rest energy is in the form of not utilized energy, and in 1.8, somewhere around 1.8 grams per calorie per centimeter square per year is lost in the form or is used for respiration. So each and every time whenever there is an energy transfer, okay, it basically takes place only the 20% of energy in each trophic level, whereas 80% of energy is being used by this particular organisms or the individuals of that particular trophic level. Okay. Now you have to also understand another concept called as the gross productivity. Now a gross productivity basically means, okay, it is the total amount of organic matter used for photosynthesis and for respiration. Okay, so that means in a autotrophs or in a particular trophic level, how much of energy is lost during photosynthesis, and for this energy, what is the amount of radiation that is used, and what is the amount of organic matter that is used for respiration. That is said to be the gross productivity. So each time when I said there is only 80% of energy that is being transferred, okay, where 80% of energy is received by that or is used by that individuals of that particular trophic level. This 80% energy is being used for, if it is in autotrophs, it is used for photosynthesis, it is used for all metabolic processes, okay, and some amount, as we all know, only 20% is being transferred to the next trophic level. Okay. Similarly, now the next gross productivities will be only 20%. Out of this 20%, okay, the maximum amount will go to the next trophic level, where this particular 80% of this herbivore will be used for its metabolism. It can be circulation, it can be digestion, it can be excretion, reproduction. All metabolic processes, okay, will take place within that 80% of energy. Okay, so I repeat, what is the gross productivity? It is the rate of photosynthesis along with the organic matter used for respiration. Okay, so I'll just brief out what is energy flow in an ecosystem. Under energy flow in an ecosystem, we have to know what is an energy, that is the ability to do work. The two laws of thermodynamics. The first law states that energy can neither be created nor be destroyed, but can be transformed from one form to the other. The second law states that no energy transfer is 100% efficient. If there is an energy transfer, it will always be from a concentrated form to a dispersed form. Okay. Now, if there is energy flow in an ecosystem taking place, it should be with respect to the different trophic levels. That is, from the producers to the tertiary consumers, where the energy flow is described in the form of a pyramid, where basically the base of the pyramid consists of producers and the apex of the pyramid consists of consumers. Okay. Now, as we all know, out of the total amount of solar radiations that falls on the sun, only 56% is received by the earth, whereas the other 44% is reflected back. Okay. Now, out of this 56%, okay,